All right, everyone, welcome back. So in this video, we're going to cover the problem set on the negative and fractional exponents, on negative and fractional exponents. So basically, what that means is I'm going to solve 5 questions related to this topic, and my goal here is to help everyone improve their understanding of the concept, right? So this video is going to touch on all the laws we've covered so far, even the more complicated ones. So if you feel the need to, go back and review those. And without further ado, let's get started with the first problem, right? So the first problem is asking us to simplify the variable quantity ABC all to the 3/2 power, right? And we're dividing that by the third root of x to the 1/2, right? Which is being multiplied by x to the negative 17th. So we just kind of want to simplify this and put it in a nice form, right? We want to clear everything up that we can, consolidate those x's on the bottom, right? Great. So let's get started with the top. So right away here, we can apply our second law of exponents to this ABC to the 3/2, right? All we need to do is multiply each part or raise each part to the power of 3/2, right? Because that's what the second law tells us to do. So right off the bat, we can rewrite this as a to the 3/2, b to the 3/2, c to the 3/2, because essentially we're raising this whole quantity to the 3/2 power, so we have to raise each individual term to the 3/2 power. We're basically multiplying 3/2 by 1, right, in every individual case. Perfect. Great, so that's all taken care of. So now let's take a look at the bottom. So the first thing we can do is, well, in the last video, I introduced a law to deal with roots. For example, the kth root of x to the m, right? That's just x to the m over k. I introduced this law, but it's good to refresh to review, right? And so we can use this property to simplify out this, right? So the kth root, it's x to the m over k, so it's x to the 1/2 divided by 3, right? That's what this would simplify to. And when we have 1/2 divided by 3, that's really the same as 1/2 times 1/3, right? Right, 1/2 divided by 3, great. And that's going to give us 1/6. So this whole thing here in the bottom is going to become x to the 1/6, great. And now all we have to do is handle this x to the negative 17th, right? So really all we have to do here is apply law 1, right? Negative 17, we have the same base. And so all we need to do is add these powers. It's going to give us x to the negative 17 plus 1/6, which is going to give us negative 16 to the 5/6. Oh, negative 16 and 5/6, sorry. Which we can rewrite. Right, we have to consolidate this into into an improper fraction for the operations. So the way to do that, right, is we're adding 1/6 to a negative 17, right? So this is going to give us a power of 16 and 5/6, right? That's a mixed number. That's all I was saying. Because when you add negative 16 and 5/6, because when you add a positive to a negative, it's going to remove itself from that negative, right? Great. So we can rewrite this whole expression as x to the power of negative 16 and 5/6. Right. Great. So if we were to rewrite this whole expression, what we're going to get is a to the 3/2, b to the 3/2, c to the 3/2, all over x to the negative 16 and 5/6. And if you remember, when we have a negative exponent on the bottom, by the negative exponential rule, we can just bring this to the top, right? And so then we're going to get a final answer. I'll erase this. X to the 16 and 5/6, that's a mixed number, times a to the 3/2, b to the 3/2, c to the 3/2. Great, so that would be our final answer for the first question here. And just a reminder, the reason I can bring that to the top in the last example is because 1 over x to the negative 16 and 5/6, right, is the same as x to the 0, because x to the 0 is 1, over x to the negative 16 and 5/6. And so when I apply that third law, well, I can just bring this to the top based on, 0 minus a negative will give me a positive. Just to review, I don't want that to come out of the blue here. Great. So let's do a few other questions. We'll do some simplification, a couple other simplification questions, right? So what if I had x to the 1/3 to the power of 1/2 to the power of 1/4? Great. What would this end up being? So we have kind of an example here to test our repeated application of law 2, right? So what would this end up evaluating to? So the way to find it, right, is we just have to apply law 2 outward, right? So we could start by, we can apply it in, well, we could start by treating this whole thing as u, right, to the 1/2, right, since it's being raised to the 1/2 power here, and then we'd have u to the 1/2 to the 1/4 power, right? And so if we apply law 2 here, right, then that would give us u to the 1/8. Right? And then all we have to do is, since we have u to the 1/8, and we know u is x to the 1/3, right? That's what I'm defining it as, because I'm taking x to the 1/3, to the 1/2, and then to the 1/4. All I need to do here is take x to the 1/3 to the 1/8. Then I multiply these two fractions together. I'll get x to the 1/24, right? That's just kind of a test of our ability to apply the laws here, right? And the reason I'm able to say this is u, right, is just because x to the 1/3 is the same as an a. It's any number, right? And so I can write it as u, and then I can just apply consolidate these two powers on the outside without having to worry about this one. And then later, I can reintroduce x as x to the 1/3, and then consolidate those two powers using law 2. So I can do it in kind of 2 steps, if that makes sense. Great. So the answer to this would be x to the 1/24. And as a bonus, we can write this as, based on that root definition, this is the 24th root of x, which means it would have to be multiplied by itself 24 times to get back to x. Or I can raise it to the 24th power, and I will get back to x. All right, great. So that's the second problem. Perfect. Okay, the third problem is going to be a bit of a different kind of, a little bit of a more straightforward one, but the goal here is just to understand some more fractional manipulations here, just like the last one. So what would happen if I took x to the 5/4 to the 4th power, right? And I took that to the q power, right? I'm introducing a new variable here, but it's the same kind of idea. Q is just another number. And I divided that by y squared, right? This is kind of just testing all of our skills. You know what? Let's make that y to the -2 power, right? Right now, this is a problem that's, again, it's just a practice problem. It's kind of testing all of our skills, our ability to apply all the laws, right? So the first thing we can do is we can say, okay, why don't we have x be equal to u again? Let's call it one variable u, since x to the 5/4 could be anything. Let's let this is equal to u, right? And so then all I have to do, right, is take u to the 4th, right? Because this is u to the 4th. If I make this u, it's just u to the 4th, right? Because it's one variable raised in the 4th power. To the q, right? And so then, all I have is 2 unique powers. All I need to do is apply law 2. And I'll get this to be u to the 4q, right? And great, since I said x to the 5/4 is equal to u, and I know that this part of value is u to the 4q, I can now plug in x to the 5/4 for u. So I'll have x to the 5/4 to the power of 4q, right? And here, again, all I have to do is another application of law 2. All I have to do is consolidate these powers by multiplication, right? Which is going to give us an answer of x to the 5/4 times 4q, right? And when we multiply these fractions, we'll see the 4 cancels. Our final result for the top here would be x to the 5q. Great. And that's fine. You may say, oh, the q looks a little strange. That's normal, right? It doesn't mean anything. We haven't done anything wrong mathematically here. It's just the fact that the q isn't a number or a straightforward variable in this case. But it's perfectly fine to have a power that's not a number, right? Great. So now all we have to do is, again, we have to bring this y to the negative 2 to the top. And as I discussed previously, this just becomes y squared, right? So since this is y squared, we can pull down the x to the 5q and get this answer, y squared x to the 5q, right? Great. That's our final answer. That's our third problem. Great, we're moving on here. You can see here, the q could really be anything. It's just a placeholder variable, right? But again, it's perfectly fine to raise things to non-numerical powers even in the problem, not just for the laws, right? That's the only point that I wanted to stress here. Perfect. So a little bit, there we go. Okay, anyway, so with 2 problems left, let's take a look at those. And the last one will be kind of a challenge problem. Thinking about doing that for these sets, just to kind of give a little more practice and help those of you who are interested develop a little more precision when coming to solving these, right? Great. Okay, so we're going to do x to the negative 1/2 times x to the 1/4 times x to the 1/8 divided by x to the 1/2 times x to the 1/6 times x to the x, right? So this is just kind of an overall simplification problem, right? Why don't we make this x to the 5/8, right? And the final answer should be written as a root for this question, right? So it looks a bit intimidating at first, right? But really all we need to do is a simplification, correct? Great. All we need to do is simplify this down into a form that looks nice and we can deal with, right? So really on the top, all we need to do is a continuous application of law 1, right? If we consolidate this and there's similar bases, and by the way, you can apply law 1. There doesn't just need to be 2 variables, right? You can have as many same base things as you want, and all you need to do is add the powers, right? And that makes sense, right? Because we could apply law 1 here, and then we just have 2 elements with base x left, and then we could apply it again, right? So it makes no difference if we apply it in one fell swoop, so to speak. Great. So we have x to the negative 1/2 times x to the 1/4 times x to the 5/8. Oh, sorry. No, that's the same thing. All we have is x to the negative 1/2 plus x to the 1/4 plus x to the 5/8. Here's a little bit of adding fractions practice at the top there. And let's take a look at the bottom. All we need to do for the bottom is add these powers again. X to the 1/2 times x to the 1/6 times x to the x, which gives us x to the 1/2 plus 1/6 plus x. All right, it's perfectly reasonable to have an x there again. Doesn't really change anything. Okay, so now all we need to do is, well, we can apply our third law of exponents and we can actually subtract these powers from one another, right? Because we're essentially dividing this one by this one. So let's rewrite that here. Great. Right? So I'm going to erase this here. And if we were to divide them, well, all we're doing is subtracting the powers, right? So first, let's consolidate these. Okay, so we have negative 1/2 plus 1/4. Well, we know that 2/4 is 1/2, right? We know that it's negative, right? We're adding 1/4. That means this is going to simplify to negative 1/4, right? Sorry, there seems to be a bit of a glitch there, but picking up where we left off, right? We can consolidate this top power to be 2/8, right? Essentially what we're doing is we've consolidated this to be negative 1/4, right? And we know that negative 1/4 is equal to negative 2/8, right? Based on this rule here. So if negative 1/4 is equal to negative 2/8, then all we have to do to simplify this top power is add negative 2/8 to 5/8, which is 5 minus 2, which is going to give us a top power of x to the 3/8. Marker's not doing so good. Great. And so now all we have to do is consolidate this bottom here, right? So we have 1/2 plus 1/6. Well, to get the same common denominator, we can multiply the top and bottom by 3. We know 1/2 is equal to 3/6, right? And so we know we're going to have x to the 4/6 plus x when we add 1/6 to 3/6. And we can simplify 4 6 by dividing both the top and bottom by 2. That's going to give us x to the 2/3 plus x, right? And now to finish this off, all we have to do is subtract the powers, right? So we get x to the 3/8 minus 2/3 minus x. Because we're subtracting the whole power, right? From this, right? And so now all we have to do is we can leave the x as is, right? But let's get a common denominator. We can multiply both the top and bottom by 3. This is 8, this is 8. So we'll have 9 minus 16 over 24 minus x, right? And this simplifies nicely to negative 7 over 24 minus x. Right? Great. And since both these are negative, right, we can split this up further. All we need to do is we can simply say, okay, this is x to the negative 7 over 24, right, times x to the negative x, right, by that first law applied in reverse, right? Great. And now all we need to do is bring this to the top, right? We can just, since this is on the bottom of the expression, and we did a subtract, actually, is it on the bottom? No, it's on the top. We can bring this to the bottom, sorry, by writing it as x 1 over, right, because we can change the negative by taking the reciprocal, 1 over x to the 7 over 24 times x to the x, right? Great. And we can rewrite this part as a root, as I said earlier. Let's do that now. We know that x to the m over k is the kth root of x to the m. Since the 7 is m, we're taking the 24th root of x to the 7th, 1 over that, times x to the x. And we're not going to do anything with the x to the x since it's perfectly fine the way it is. We don't need to turn that into a root, right? And that's our final answer. The reason we don't need to turn it into a root is because there's no fractional power there. It's a lot nicer just to leave it with a nice exponential power. All right, great. So I want to do one challenge problem. I'll explain the solution, but I don't necessarily expect everyone to get it here. It's a bit of a complicated one, but I do think it's worth exploring. The challenge problem is this. What if I had x times x to the 1/2 times x to the 1/4 times x to the 1/8 times x to the 1 over 16th, right? I just keep doing this on and on and on, right? What is this equal to, right? That's the question. Well, how do we even approach this, right? We just know that this power here is shrinking every time we multiply it out, right? So the first thing we can do is apply our laws of exponents, right? So we'll get x to the 1 plus 1/2 plus 1/4 plus 1/8. Great, right? So this would have to simplify to something, right? So how could we potentially simplify this? We know this is going on to infinity, right? So maybe let's take a look at that. Take a look at the power here. Let's set that equal to u, like I've done before, right? Now, if we notice here, we can rewrite this as 1 plus 1/2 times 1 plus 1/2 plus 1/4, right? If we factor out a 1/2 from all these, like if I were to distribute my 1/2 back into here, I would get back to the original series, right? Of numbers, right? That's equal to u. And if we look on the inside, this is also equal to u, right? Great. So since that's also equal to u, and I know this is a bit of a complicated leap, but we factored out that 1/2 to get to this step, right? We can simply solve this as an equation. We can say, okay, 1 plus 1/2 u is equal to u, right? And now it's just, we can subtract 1/2 from both sides, 1/2 u minus 1/2 u. We'll get 1/2 u is equal to 1. That means that u is equal to 2. And remember, u is this whole thing. which means, since u is equal to 2, that all we have here is x squared. All right? That's kind of a challenge for problems. It's not necessarily important, but it is an interesting question, right? So basically what this is saying, if we convert all these into roots, is that x times the square root of x times the 4th root of x times the 8th root of x will actually eventually equal x squared, right? If we keep multiplying these things by one another, eventually they will end up equaling x squared. It's very interesting, right? And so with that said, let's do a recap. These were just the problems, right? But a recap of things to know for this chapter, or this section rather, are the laws of exponents, right? Laws of exponents, there's 3 of them. Negative exponents, fractional exponents, and roots. Great, so that's basically all you guys need to know, right? And with that being said, I will see you guys in the next video.